In this video, we're going to derive the antiderivative of secant cubed theta. And one fact we're going to need is that the antiderivative of secant theta d theta is natural log of absolute value of secant theta plus tangent theta. If you want to see how that's done, I have another video for that, and I'll put it down in the description. So, when we go to do this, may not be real obvious how to start, but actually we're going to start with an integration by parts. And I'm actually going to split up the secant. I'm going to use just secant theta for u, and then secant squared theta d theta for dv. The reason I do that is I can calculate the antiderivative of dv very easily. It's secant theta. And the derivative of u, we also know it's secant theta tangent theta d theta. So my choices were based on the fact that I know the derivative of secant very easily and the antiderivative of secant squared very easily. So that may help when you're doing integration by parts how you choose these things. So let's put together our integration by parts. So we have antiderivative of secant squared is tangent theta. My mistake. So our uv is going to be secant theta tangent theta minus the integral of v du. So tangent theta times secant theta tangent theta d theta. Now we'll combine those tangents. So we have secant theta tangent theta minus the antiderivative of tangent squared theta secant theta d theta. Now we're going to use one of our handy Pythagorean identities, and that's the one for tangent squared. Tangent squared theta is equal to secant squared theta minus 1. And I'm going to sub that in for this tangent theta here. Now this part's already done. That's going to end up being part of our antiderivative. And now plugging this in, we plug in the secant squared theta minus 1 in parentheses, secant theta d theta. Now I'm going to distribute this secant theta and see what I have, see where I'm at. So I have secant theta tangent theta minus the integral of secant cubed theta, because we got a secant times a secant squared, minus secant theta d theta. Now our initial thought might be, well, hey, great, that's what we were trying to find with secant cubed. That's actually going to work out to our advantage. Check out what we can do here. I'm going to split that into two integrals over subtraction. So I'm going to have minus the integral of secant cubed theta d theta. And now this negative and this negative are going to combine to be plus the antiderivative of secant theta d theta. This one we don't know how to do. It's what we're looking for. This one we do, though. If you remember, we said earlier the antiderivative involves a natural log. So this one we're going to calculate. This one I'm going to leave alone for right now. So I have secant theta tangent theta minus, and I'm just going to leave it as an integral, secant cubed theta d theta, and plus the natural log of the absolute value of secant theta plus tangent theta. And now remember what we're trying to solve for. This all started all the way back up here. This was to solve the integral of secant cubed theta d theta. So what I'm going to do is I'm going to add secant cubed theta d theta to both sides. This is a really useful trick on some of these that we start to see them just repeating, because it cancels over here. And so what I end up with over here is 2 times the integral of secant cubed theta d theta equals secant theta tangent theta plus the natural log of the absolute value of secant theta plus tangent theta. And last thing I have to do is divide both sides by 2 or multiply by 1/2. So dividing by 2, and let's just take this side and multiply it by 1/2, and we'll get our plus c on the end, and there we have the antiderivative of secant cubed.